Hey guys, so this is still solving systems of equations, but this one in particular is solving systems by elimination, as you see here. And you can read through the steps, but I'll tell you in my own words. Um, Basically, when you're solving a system of equations by elimination, one of the first things I want to have is I want to have between the two equations, I kind of want to have the like terms aligned, meaning like the x is aligned as you see here, the y's are aligned, even the equal signs are aligned, and the constants. So that's one of the first things I'd like to have. Again, solving by elimination, everything aligned. So if everything is aligned like this one, the next thing I do want to have in place is I want to have opposites for either the two different x terms or x values, or the y values. So opposites are like 10 and negative 10, or 15 and negative 15. So as you can see here, I also have opposites already in place on the x terms. So since everything's aligned and I already have opposites, or inverses if you want to call them that, I can just add, or I guess however you want to think about it, add or subtract, but I can just add the two equations and eliminate one of the variables. Well, actually, one time a teacher told me that when you eliminate your variables, you are the eliminator, kind of like the Terminator, but the eliminator. So anyhow, if you do add your two equations, 3x plus negative 3x is 0, so that's why it's gone. Negative 4y plus 2y is negative 2y, as you see here. 11 plus negative 7 is 4. Again, you see that, you solve it, you get y equals negative 2. Once you solve for one variable, you take that answer, you plug it into the other equation to get the other variable. Or should I say, you plug it into one of the original equations to get the other variable. So you can see here I plugged a negative 2 in for y into the top equation, and I went ahead and solved it, and I got x equals 1. So my final answer is that x is 1 and y is negative 2, which is aka the ordered pair 1, negative 2. Remember, it's always x first, y second. And one last thing is I'd probably plug 1 and negative 2 in for x and y into the bottom equation to check it. So I'd at least mental math, if I could do that. Negative 3 times 1, right? So that's negative 3, and then 2 times negative 2 is negative 4. So I'd have negative 3 plus negative 4, and negative 3 plus negative 4 is negative 7. So the ordered pair does work in both equations. Moving along to the next page, you see this equation here. It actually does have the terms all lined up. The x terms are lined up, the y terms are lined up, the equal signs and the constants, everything's aligned. But what I don't have is opposites. So, right, the opposite of 3 would be negative 3, or the opposite of 9 would be negative 9. Same thing here, 8 and 2 are not opposites, but the opposite of this minus 8 would be a positive 8 there. So I have a couple options here. First of all, you are going to multiply to make opposites. You're going to multiply one or both of the equations to make opposites. You could, if you look at this note here, it says you can multiply by negative 3 or 4. If you multiply the top equation by negative 3, you're making the opposite of 9, right? Negative 3 times 3 is negative 9, so it'll cancel out with this positive 9, and you can see that's what I did. But over here I was just advising you could also multiply by 4. If you multiply the top equation by 4, then 4 times 2 will be 8y, and it'll be the opposite of negative 8y. So there's definitely a couple options for multiplying here to make opposites. And then anyhow, you see what I did. I multiplied the top equation by negative 3 to make a negative 9x, which will cancel out with this positive 9x in the bottom equation. In doing so, I also have to multiply everything by negative 3. So negative 3 times 2 is negative 6. Negative 3 times 48 is negative 144. And the whole point of multiplying the top equation by negative 3 was to get this 9x and negative 9x. It will zero out, and then the rest I can solve. Negative 8 plus negative 6 is negative 14. Negative 24 plus negative 144 is negative 168. And then solving that, I'd get y equals 12. And once I get y equals 12, I can plug that 12 back into either of the original equations. So I used the 3x plus 2y equals 48, plugged in a 12, figured out that x equals 8. So my final answer is that x is 8 and y is 12, aka the coordinate pair 8, 12. You might want to try that coordinate pair in here. 9 times 8 is 72, minus 8 times 12, which is 96. 72 minus 96 is negative 24. So I would just kind of mental math check my work. Here's what I called scenario 3, right? I actually did label these. So scenario 2 was where I needed to multiply one of the equations. Scenario 3 here is where I need to multiply both of the equations to make opposites. If you look at this, everything's lined up like I want it, but 4x and 6x are not opposites, 6y and 9y are not opposites, and there's no numbers I can multiply 4 by to get a 6, and there's no numbers I can multiply 6 by to get a 9. So in this case, I had to multiply both equations. I could multiply both equations to get opposites on either x or y. So I went ahead and decided that I'd make opposites of the x's by making a negative 12 and a positive 12. So the way I can multiply 4 times negative 3 to make a negative 12, I can multiply 6 times 2 to make a positive 12. And so I went ahead and did that. I multiplied both equations to make a negative 12 and a positive 12, but what ended up happening was the y's ended up becoming opposites in that same step. So everything on the left side zeroed out, but on the right side I ended up with a negative 12. And hopefully you guys remember that if you do end up with something like this, 0 equals negative 12, that's definitely not true. So it's no solution, as this symbol means. And no solution basically means that these two lines would never touch. If we were to graph these two lines, they'd never touch, aka they'd never intersect or cross, and that's why there's no solution. So aka they're parallel lines, they would have the same slope. As we move along here, we can see in this one, back to just kind of more practice, I made opposites out of the x's by multiplying by negative 2, right? The opposite of 4x is negative 4x, so if I multiply this 2x by negative 2, I can get the negative 4x that I'm talking about, and then the rest still needs to be multiplied. Negative 2 times negative 3 is a plus 6y, negative 2 times 7 is negative 14, so this is the equation after multiplying it by negative 2. 4x plus 5y equals 3. Well, I just copy that down again, and then when I add these equations, the x's cancel out, and I end up with 11y equals negative 11, which gives me y equals negative 1. And once I get y equals negative 1, I plugged it into this equation here, negative 1 for y, and solved it, and I got x equals 2. So you see my final answer here, 2, negative 1. And I might just take, again, mental math and check 2, negative 1 in this equation here. 4 times 2 is 8. 5 times negative 1 is negative 5. So 8 plus negative 5 is 3. So it works there. Let me go ahead and take a look at this last one. See, this last one has a couple things going on. This is yet another scenario. I called it scenario 4, where you need to rearrange the terms so that the like terms are aligned and then make opposites by multiplying. So you see how it's all kind of out of whack here. The x's don't line up. That's an x and a y term. The equal signs line up, at least that. The constants are actually lined up. So what I did was, as you can see here, I moved the 4y over to the left and the 3x over to the right. You can see that in this equation. And then I left the bottom equation alone. So I only rearranged the top equation, and I know it looks a little different than what we've been using, but at least it has everything aligned. Once I aligned everything up, I multiplied the top equation by negative 2. That would make this into a positive 6x, which is what I was trying to make the x's opposites. So I multiplied the top by negative 2 to make a positive 6x, and the bottom by 3 to make a negative 6x. So I made the x's opposites, and the rest just kind of plays out as whatever it plays out to be. So negative 2 times 4, negative 8y, negative 2 times 2 is this negative 4 right here. 3 times 5, 15y, 3 times negative 1 is 3, and then So anyhow, multiplying it out, here's my equations. Negative 8y plus 15y is 7y. Negative 4 plus negative 3 is negative 7. The x is 6x, and negative 6x zero out. So solving this, I got y equals negative 1, and then I plugged a negative 1 in for y into this bottom equation, and you can see I worked it out and got that x is 2. So my final answer is 2, negative 1. And I might just test out 2, negative 1 in this top equation here. Y is negative 1, so this would be 4 times negative 1, which is negative 4. And then 2 minus 3 times 2, well, that's 2 minus 6. And 2 minus 6 is negative 4. So again, just mental math checking my answer. So hopefully that helps, guys. Do your best to get the 6 practice problems done. And we'll move along tomorrow.